Ecohydrology is very broad, and I think it's really important to not be too narrow in defining it, but I think ultimately thinking about the role that plants play in the water cycle.
So for my research, it's a kind of a new field. It's been around for. So how can there be frontiers of this new field? Because you're presenting the frontiers of ecohydrology today, convening sessions for that.
Yes, so the Frontiers in Ecohydrology is the sponsored session from the Ecohydrology Technical Committee, which is under the hydrology section for AGU. And the idea for this section was to provide an opportunity for young scientists and established scientists to have an opportunity to just share what they're really excited about, what's new and novel in their small sub area of ecohydrology that they can share with the rest of the community.
And you are a convener in some of these panels, in these sections, is that right?
Mm-hmm.
And so as a convener, you really get to decide whose work is showcased to sort of help shape the future of the field. How did you choose which sessions you would include?
Yeah, so I think it starts all the way from when we're soliciting abstracts after our session gets accepted from AGU, and we really just try to cast a really wide net so that people who might not know that our session exists can find us and see that it's an opportunity for them to display their work. In terms of deciding, who gets a poster, who gets a talk, as a committee, we really use a democratic process, and something that we also consider, once everyone votes are, well, what does the demographic of our speakers look like? Are we also highlighting junior career folks? Are we giving grad students an opportunity to present oral talks rather than just all posters? Do we have a good mix of diversity in our speakers in terms of the fields that they represent, the backgrounds that they have, or the experiences they've had?
As a convener, do you look for people like come from the places that you're studying and wish that you could have had this representation and a voice at AGU?
That's a really good question. I feel like I had opportunities as a grad student to give talks and posters. And so I think it's just making sure that when we see students who've submitted or, more senior folks, that we're making sure that we're providing those opportunities equally. Yeah.
I would love to really get into the nitty gritty of the decision making process, but I also know that you want for us to be kind of a black box, as I've heard so many times over the past few days.
But I don't know if it's not supposed to be a black box.
if you have two that are very close,
yeah,
and you have to break someone's heart, what's that decision like?
It's still very democratic. We talk as a group and give people an opportunity to really make a point. And I think something that someone in the committee was really a good champion for this year was making sure that we were doing a good job representing our international colleagues, since it is AGU, and a lot of times we tend to focus on folks who are here in the US, but making sure that we're also highlighting the great work of our colleagues that are not in North America. Yeah.
I know part of convening a session is you get to do the big walk. You get to walk down the poster aisle and see all the people there, and when you come by, they straighten up a little bit because they know. What was that like for you over the past couple of days?
What I think that when I'm in the role of a convener, I think about when I was a student and what I really appreciated from conveners. And as a student, I always appreciated when the convener introduced themselves and listened to my pitch for my poster. And as a convener, I just try to make sure that I give that opportunity, especially to the students, but also to anyone else who hasn't had anyone come up and ask questions yet.
That always makes me feel, when I'm walking through the poster hall and I see someone standing there with that forlorn face of nobody's asked me about my stuff in half an hour and I have 3 more hours to go. How did you handle that as a student and as an early career presenter?
I have a funny anecdote. I think it was my first conference I ever went to. It was not AGU, a non-AGU conference. And I went to present, and there weren't really any hydrologists there or any people who studied the water, and no one came by my poster. And finally, this other person who was presenting across the aisle from me came over, and they were like, "It's because you have water in your title. No one wants to talk to you." And I think that, it was my first time, so I don't think it made me sad, because I was probably more nervous to talk to anyone, than to just sit there quietly. But I think that it was a really good lesson early on in terms of knowing your audience and making sure that if you're trying to get a lot of engagement when you're at this kind of, when you're at a conference, making sure that you are presenting, things that are relevant to the people who are there, but yeah, also communicating things that would be interesting, even if it's something that, a person in this other field wouldn't necessarily normally stop by. Yeah.
There's a selection in sessions from broad ideas of like, we're looking at the future, to very specific things of like, we're looking at a molecule. How did you find that balance as a convener?
That's very funny. I think I think sometimes we cop out and we're like, we want to look at studies that tackle these processes across scales. And then you can include everyone, which is really awesome. And that's definitely something that we do with the Frontiers in Ecohydrology session. We want to make sure people know that it's a session for them, even if they study things at, the molecule scale, all the way up to the global scale. If they do field work, if they do data analysis, if they do remote sensing or modeling, it's a space for them. Yeah.
Everybody in there. Let's ask this one. You mentioned that you're studying water early on, and now you're doing plants, like all this stuff in the eco-hydrology space.
Yeah.
Why does water fascinate you?
That is a great question. I think, so to be totally honest, what initially got me into, wanting to do research in earth sciences was I was fascinated by cloud formation, and obviously clouds play a big role in the water cycle. And I don't study clouds now. I guess I do a little bit of work with fog, which more recently, which has been really fun. But yeah, I think that clouds fascinated me. And then when I realized that, there's a lot of uncertainty in both cloud formation and plant processes, I had to sort of choose, and I went with plants, and I've loved every minute of it.
You mentioned the fog, and I know in one of the sessions it was building a 3D printed fog analysis machine. Yeah. When that abstract crossed your desk, what was that like for you? Yeah.
So, the projects that you get that you don't expect. That was definitely one of those. This came out of an SF-funded project that we have in Costa Rica, looking at how the forests will respond to climate change in these areas where we get lots of low-lying cloud and fog. And so these forests are very much adapted to being in very humid, very foggy, very cloudy environments. So obviously a big part of this project is measuring fog. But once we were funded and we were looking to buy some sort of fog screen, we found that it was either very expensive or too nearly impossible to find anyone to build it for us. So as the engineer on the team, I volunteered. I thought, I've had to teach 3D printing to my students. I'm sure we could figure out a way to 3D print something, and then it would be low cost, and maybe it's something that if we have a need, other scientists have a need for it. It also seemed like a great project to get undergrads involved in, because they love when they can build something with their hands and do actual experiments in our lab. And in a lot of ways, it led to a lot of great connections within my building with people that I don't normally work with, the tinkerers in our makerspace. And yeah, it really came out of a need because we didn't have the instrumentation, and now it's turned into something a little bit bigger where we're hoping to publish a technical note, and we've had 2 undergrads working on this project, which has been really fun. And our end goal is to make plans that are freely available for other scientists who might want to build their own fog gauges. Yeah.
That's right along the lines with the open access and all the open stuff that they're talking about at AGU. Let's ask about that a little bit, because that's sort of a movement, is open access data, open access research. And is that something that you support?
Absolutely.
Why? I mean, you spend a lot of money and there's a lot of time. Don't you want to keep all your data to yourself?
I think that data is better when it's getting more use than being locked up tight and not being shared. So I completely understand the need for people to, hold on to their data until they're done publishing with it. That of course makes a lot of sense. But for me, I feel like if someone else has interesting questions that they can answer with my data and that they're able to, that I wouldn't think of, why not make it freely available and shared?
Give it away. You mentioned the fog analysis project gave you a chance to connect with people you usually wouldn't connect with, and you're a collaborator with the Critical Zone Collaborative Network, which also lets you connect with people you usually wouldn't connect with.
Yeah.
You must have had a choice when someone, Julia maybe, was like, hey, do you want to be a part of it? What was that thought process like, and what made you finally say, yes, I do want to join?
So before I got connected with Julia, it was actually Holly Barnes, who's the lead PI in the Dynamic Water Cluster, and she's been a wonderful mentor for me for many years now. And she was the one who said, hey, here's an opportunity for you to apply for a grant, and you would get to be part of this Critical Zone network. And my initial thought, I don't think I said this out loud, but I was like, do I belong? Am I a Critical Zone scientist? I didn't know. But she was like, of course, you would fit in perfectly. It's a great opportunity for you to build your network and meet new people. And I thought, you know what, I'll give it a shot. And luckily, I was one of the fortunate people to be funded and have the opportunity to meet all of the other PIs in the Critical Zone network. And so I think it started really slowly. I met Julia in one of the Zoom calls that we have with all of the PIs. And then over the summer, or actually last AGU, I finally met Julia in person. And she's just a lovely person. And I'd like to say one of my new mentors as well.
I am so fortunate to have met her and that she invited me to join the cluster. Yeah. Working with her is great, and I'll be sure to cut this part out because she doesn't like to hear that too much on the one of the things that I found so fascinating about what you bring to the specifically the cluster that I work with and know the most about is the plant part. Plenty of hydrologists, soil scientists, wildfire recovery people in there, but you really bring the plants to it. When you look at, like, there's trees right over there, what do you think of when you see a tree?
I think of all of the complexity that we don't incorporate when we try to model these things, or that we can't see when we're trying to sense them with satellite data.
So it's not what you see, it's what's not there.
Pretty much, yeah. What I've really enjoyed about the collaborations that I've started since I became a faculty member and started doing my own research projects is just seeing the way that other people think about problems. And it's completely changed, when I get to go to field sites with different people and I get to see things through their eyes. It's made me, for me, it's opened up so many new interesting questions and hypotheses. And honestly, I feel like that ultimately drives my work at this point, is just sort of looking at that tree and observing and, putting on my hat, the lens that I think my ecophys collaborators would have, or the hat that I think my, drought collaborators would have, or some of the people in big data would have. It's really made a difference.
You made me think of this thing, and yesterday I watched you present talk about the drought stuff. And that's a big, serious, very, very important thing, especially as the climate continues to warm and we face this climate crisis as humans. What do people understand about drought, and what do they not understand about what a drought is?
This is a great question. And I think it's a very interesting question to ask me as a scientist versus like me as a person who, just lives in an area that sometimes has a drought. I don't know if you're aware, but right now North Carolina has been in a pretty severe drought for the past couple of months, and it's created a lot of wildfires. And so it's, when you ask that question, as a person who just lives in an area that's currently affected by drought, I'm thinking about, how is this affecting, the people who are trying to manage lands where the soils are now very, very dry, or the areas where they want to do controlled burns, but they can't because it's too dry, or the people where there are currently wildfires going on because the forests have become so dry in the mountains, how that's just affecting their air quality and their ability to enjoy being outside. Versus, from the scientist hat, I can think of, all the variables that I wish that we could measure better so that we could do better forecasting as well, to help eventually help people, but also just improve our fundamental understanding of it, if it gets drier, or, how do we better define, what creates conditions that then plants will respond to. But I think it's really, I think in terms of the work that we do versus like being people, there's a big difference because, modeling plants, sometimes, thinking about my work and publishing the papers, it's not necessarily like helping the people who really need it right now,
I'm going to follow up on that just a little bit because another person, undergraduate researcher, was talking about that weird dichotomy between being excited about data that you're seeing, and then you take a step back and say that's actually really devastating for the people. How do you hold both of those things at the same time?
It's hard. It's especially hard with the work that we do around wildfires in North Carolina. When there's a fire, this is a great opportunity for us to study this fire that occurred and how plants are responding to it and what conditions looked like before and after. But as a person who, frequents some of these areas or knows that, say, if we have a lot of fires by the coast, those are really important tourist areas. It's very important for the people who live and work there, that people are out and about. And when, air quality is poor, people don't go and visit those areas. So I don't know if I have a good way of balancing the two. I think just making sure that I'm always thinking about how it's impacting people and not, only focusing on how this can, advance the research that we're doing, because it's not all that matters.
Everything that you're saying just reinforces how intricately connected all of these complex systems are.
Yes.
Wildfire means no economic boom from a summer tourism at the beach. Yeah. And those are connections that people, they're so busy raising their children, feeding their family, going to their job. Do you have a responsibility as a scientist to think at that high level?
I think as a human, we have a responsibility to think about our other fellow humans out there and, not always be so absorbed in our lives or our careers. And, even if we can't necessarily help, just having empathy for what others may be going through.
I have a couple more questions for you, and then you can get right back out into the madness. How do you balance teaching, research, a personal life, preparing for conferences, presenting at a conference, writing grants? How do you balance all of that stuff? There's a lot going on.
I would say that it's not, I don't use the word balance anymore because those things cannot exist in a balance. I would say that what has been really helpful for me is when I can do a good job of prioritizing what's most important now to work on versus what can wait till later, because I can't do it all at one time. Right now we're at the very end of our fall semester, and when I'm teaching, obviously my class and my students has to be a top priority, which means that sometimes the grant writing or the paper writing or, some of my personal life gets pushed to the margins a bit so that I can make sure that I'm doing my best for my students in my classes. I'd say like the second priority would be my research students. They've decided that they're going to give me their time So I want to respect that and give them my time. I do definitely make sure that I make time for my family, and I think we all try very hard to have good boundaries, so that we can make sure that happens. And some days it's easier to enforce those boundaries than others. But yeah, I think it's just really thinking about in this moment what's important and what can wait, because there's no way to balance it all at the same time.
I like balance is not even a thing. One little question about teaching and working with students is, describe to me what it's like for you when you see that spark in that student's eye when they get it, or they're suddenly excited about science in a new way, or you see suddenly something in their face exchange like, oh, they have a path that they find. What's that like for you?
Oh, I love it. It makes me so excited. Obviously, I teach because what I teach excites me. And so I even, when the students aren't so excited, I can bring my own energy to the classroom. But yeah, when they give me that energy back, when, I see the light go off, or they're starting to ask really good questions, or, they're really proud of themselves. Yeah, there's nothing like it. It's super rewarding. I had, maybe 2 years ago, I was teaching a class, one of my technical electives, and I always ask, why did you sign up for this class? And one of the students that year responded, I needed the credits to graduate. And of course, that's fair. That is a fair reason to be in the class. But I really started to see him engaging with the material, not just doing the bare minimum. And by the end, he did a really cool project related to quantum physics. And seeing him so interested in something that he didn't know about before, and two, seeing that like he has more value, I think, than what he initially thought he had in the classroom, that was a really rewarding experience.
My last question for you is, humans have been doing science for millennia. Why is there still science to do? Haven't we learned all the stuff we need to learn?
No. I mean, if that were true, we definitely wouldn't have, 20 to 30,000 people here now. I think there are a couple of things. Do we know everything about the Earth system? No. And I think that we're constantly learning, not only about maybe new processes that we didn't think or think to look for even, or had observed before, but even different ways to think about what we have observed, which I think will always mean that we're advancing and having new science. But I think that also as society evolves, the science that we do naturally evolves with it. So I don't know if we'll ever run out of science.
You're just saying that because you don't want to run out of funding. I know, but there's always more work to do. I did think of one more thing, which is, I heard you say yesterday, someone asked a question at the end of one of your sessions, and you talked about the importance of communicating science to people, about why it matters to them. Why is science communication so hard? Because if science communication was easy, we wouldn't have a climate crisis. 50 years ago, we would have stopped using fossil fuels then, not have some sort of agreement at COP28 today to stop moving. Why is it so difficult to communicate science to people?
I think it just has to do with how we're all trained. When you're trained as a scientist, you're trained to communicate with other scientists, and not necessarily one across different scientific disciplines, but to, with people who aren't in scientific disciplines. And so I think that's an important part of our training, that at least these days, I think a lot of us are doing a better job making sure that our students are getting training in science communication, so that they can be the change that we would have loved to see maybe 50 years ago. But yeah, I think that there's so much to learn about how we can do science better from people who aren't in our disciplines. When you look at where some of the great ideas come from. It's usually someone saw a framework in one discipline or a model in another discipline and said, hey, maybe we could use that to describe this phenomena that we're seeing over here. So that being a reason for communication being really important. But also, if you talk to the average farmer, they're very aware of climate change. You don't have to convince them, they see it. And so I think also, making sure that we're listening to the experiences of people who are directly being affected by the things that we're studying, being a great way to also inform new hypotheses and directions for us that are not only interesting, but maybe will be really relevant.